Hello children, we'll continue with chapter 8, sound propagation. We'll have to do the numericals here today of part A. Theory we have completed. We'll be starting with the numericals of part A. Okay, and what are the formulas that we'll be using? Mainly B is equal to F lambda. The formula that we'll be using is B is equal to F lambda, where B is the velocity or speed of sound, F is the frequency, and lambda is the wavelength. And another formula, F is equal to 1 by T. Okay, these are the two formulas that we will be using. And another one, velocity is equal to distance upon time. Distance upon time. This is also another formula that we will be using. So before solving the numericals, you can write all the formulae, okay, it's plural, that we'll be using in the solving the numericals. V is equal to F lambda, F is equal to 1 by T, and velocity or speed is equal to distance upon time. We'll start with the first numerical. The heart of a man beats 75 times a minute. What is its frequency and time period? Okay, so first write whatever is given. That is, it beats 75 times in 1 minute. Okay, now we have to find frequency and time period. If you remember, the definition of frequency is number of vibrations produced in 1 second. Number of vibrations produced in 1 second. So here it's given 1 minute means 60 seconds. So in 60 seconds, 75 times it vibrates. 75 times the heart vibrates in 60 seconds because it was given 1 minute, 60 seconds. But I need in 1 second how many vibrations will be produced. That will be 75 upon 60 times it will vibrate. And that is the frequency. Because according to the definition, frequency is the number of vibrations produced in 1 second. So in 1 second, okay, so if I cut by 15, 5 by 4. So 5 by 4 will be 1.2. Okay, don't write times. Now because you are writing as frequency, either you will write second minus 1 or you write hertz. Leave second minus 1. You get used to writing hertz. Unit of frequency is hertz. So F is 1.2 hertz. So you find number of vibrations in 1 second and then that will be the frequency. And next you have to find the time period. So as I told you, time period is 1 upon frequency. If frequency is 1 upon time period will be 1 upon frequency. So 1 by 1.2, or you can write this 5 by 4. So it will become 4 by 5, which is equal to 0.8 seconds. 0.8 seconds. Okay. So time period is 0.8 seconds. Frequency is 1.2 hertz. I hope you are clear with this numerical, children. Okay. Second is homework. We'll do it as homework. You can pause the video and do it continuously. Okay. So pause it now and do the second one. That is the homework. Then I'm going to do the third one now. It will be good if you write the numericals continuously. That's why I'm saying you can continuously do the numericals. Now, we go to the third one. The separation between two consecutive crests in a transverse wave is 100 meter. If wave velocity is 20 meter per second, find the frequency of wave. Now, from the definition of transverse wave, you know that the distance between two consecutive crests. You remember the diagram of transverse wave? It will be like this. And distance between two consecutive crests or two consecutive troughs is the lambda, the wavelength. Can you understand? So if they are giving separation between two consecutive crests, then they are giving the wavelength. Is it clear? So you have to, while noting down, don't write the distance, something like that. You have to take lambda, wavelength lambda. Okay, for first sum you try to write it fully. Wavelength lambda is equal to 100 meter. If that is the case, and wave velocity V is equal to 20 meter per second. Now the question is, find the frequency of the wave. We have to find the frequency. Now we have to use this formula, V is equal to F lambda. So what will be F? So we know that V is equal to F lambda. So F will be V by lambda. That will be 20 upon 100. 1 by 5. That will be 0.2 hertz. Its frequency. So unit will be hertz. 1 by 5 will be 0.2 hertz. Is it clear, children? So identifying this as the wavelength is the very important thing. Okay, they have not given directly as wavelength. Distance between two consecutive crests. So that is based on the definition, that's the wavelength. So I use this formula to find it. Again, fourth is homework. Now in fourth, I would just a longitudinal wave of speed and frequency. Find the separation between two consecutive compressions. What is that? Separation between two consecutive compressions is the wavelength. So they are basically asking you to find the wavelength. So in this question, near two consecutive compression, you can write wave lambda and keep. They are asking you to find lambda or the wavelength. Okay. Next, we'll do the fifth one. Fifth question. A sound of wave produces 40 crest and 40 trough in 0.4 seconds. What is the frequency of the wave? Okay, so lots of things, definitions, okay, you have to use in this. Now, one crest and one trough form one wave. Remember, one crest and one trough forms one wave. So, 40 crests and 40 troughs will form how many waves? 40 waves. 40 crests and 40 troughs form 40 waves. This is the first thing you should be able to identify. Okay, if they are given 40 crest and 40 trough, means there are 40 waves. So these 40 waves are produced in 0.4 second. What is the frequency? So 40 waves are produced in 0.4 seconds. We have to find the frequency. Frequency is number of vibrations produced in 1 second. Okay, if I find for one wave, that will give me the time period, but they have asked me they've asked the frequency. So let's write the reverse way. 0.4 in 0.4 seconds, 40 vibrations are produced. So in 1 second, how many vibrations will be produced? 40 upon 0.4. So that will be 400 by 4, that is 100 hertz. 100 hertz. Is it clear, children? Okay, so be careful. The other way I would have written, if I would have written 40 waves are produced in 0.4 second. So one wave is produced in 0.4 by 40. That will be 1 by 100. That will give me the time period, because time taken for one wave will be 1 by 100 seconds. Okay. So if they are asking you frequency, then you have to find number of vibrations produced in 1 second. Okay. These are very simple the calculations are not big, but then the concepts, the definitions, you need to be very clear. After this, you can do the sixth one. Okay, this is simply distance and speed are given, you're asked to find the time. Distance and speed are given, you're asked to find the time. You'll use this formula. Speed is equal to distance upon time. The same thing, 7th is also homework. 6 and 7 are homework. Continue, okay? You can, after this, you do 6 and 7. Complete that, then come to the 8th one. I'm going to solve 8th one now. Okay, let's read the 8th one. A boy fires a gun and another boy at a distance hears the sound of fire 2.5 seconds after seeing the flash. Okay, 8th one is also homework, I'm sorry. 6, 7, 8, all the three are based on speed is distance upon time. Okay, right, we'll do the 9th one now. 9th one. An observer sitting in line of two tanks watches the flashes of two tanks firing at each other at the same time. But he hears the sounds of two shots 2 seconds and 3.5 seconds after seeing the flash. If distance between the two tanks is 510 meter, find the speed of sound. Let's go one by one. An observer sitting in line of two tanks. Okay, so it's good if you will draw a diagram. There are two tanks. Tank 1, tanker, right? Tank 2. And an observer is sitting here in the same line. Observer is sitting in the same line. Watches the flash of two tanks firing at each other. Okay, they were firing at each other. And he is watching from here. So he'll be seeing the fire and hearing the sound also. Okay, it's given. But he hears the sound, two tanks firing at each other at the same time. But he hears the sound of two shots 2 seconds and 3.5 seconds later. That means from the nearest tank, he would have heard the first sound. Is it clear? So the sound that he heard first, that is after 2 seconds, he would have heard from tank 2 because that is closer to him. Then from tank 1 to tank 1 to his to the observer, it would have taken 3.5 seconds. Is it clear, children? So this is the first thing you should know. He hears two sounds, one after 2 seconds, one after 3.5 seconds. So the thing you should use is, from the nearest tank, he would have heard the first sound. So time taken here is 2 seconds. Time taken by the sound to travel from here to here is 3.5 seconds. Okay, one more information is given. What is that? If distance between the two tanks is 510 meter. Now the distance between the two tanks is 510 meter. Distance between two tanks. Okay, we'll start use from here. This distance is 510 meter. Then what they've asked us to find speed of sound. Find the speed of sound. Okay. Now, with this distance I can't do anything. Okay. So, let me assume the distance between so how in this distance, what is the time taken by? Now the times that they have given are from tank 2 to the observer, tank 1 to observer. We need the time taken by the sound to travel from tank 1 to tank 2 because the distance is given of that only. This distance is given, so I need to know the time taken by the sound to travel from tank 1 to tank 2. What will be that? 3.5 minus 2. This is 3.5, this is 2, so this will be 3.5 minus 2, that is 1.5 seconds. Is it clear, children? So now distance is 510 meter. During this distance, the time taken by sound, for this distance, the time taken by sound to reach is 1.5 seconds. Is it clear? You should not use any of this time because they are not the time taken for the sound to travel between two times. So remember that. So you subtracted it and that will be the time taken by the sound to travel between the two times. Now, once you know this, we can find the speed of sound. Speed is equal to distance upon time. 510 by 1.5 or 5100 upon 15. So 3 15s are 45, 60, 4, 0. 340, what will be the unit? Speed. So meter per second. Speed will have unit as meter per second. Remember that. Have you understood, children? So this is how 9th one has to be done. And one more numerical I'll be doing. 10th one, 11th is homework. So we'll go to the 10th one now. How long will sound take to travel in an iron rail and air, both 3.3 kilometer in length? So distance is given. So there are two things. One is an iron rail. The first one is an iron rail, and the second one, the sound is traveling through air. And it's given the distance in both the cases. Distance is the same, 3.3 kilometer. 3.3 kilometer. Here also distance is 3.3 kilometer. So you have to convert it into meter. That will be 3.3 into 1000. That is 3300 meter. 3.3 into 1000. That is 3300 meter. So in both the cases, distance is same. Take speed of sound in air to be 330. In air, the speed of sound is 330 meter per second. Okay, speed of sound in air. And in iron, it is 5280. So speed in iron is equal to 5280 meter per second. These are the informations given and you have to find how long will sound take to travel. We have to find the time taken. Okay. So, V is equal to D by T. T is equal to distance upon velocity. So, D by V. That will be D is 3300 upon velocity is 5280. And here again time is equal to, so here V in iron, here time in air will be distance upon V in air, that will be 3300 divided by 330. So this will be 10 seconds. Okay, this cutting will be very easy, 10 seconds. Now here if I do by 3, 110, 1, 22, 7, 6, yeah, it goes in 11, 10, that, and then 1, 16, 10 by 16, 5 by 8. Okay, so 5 by 8 is 0.68 are 48 to 20, 16, 5. So 0. So if I divide 5 by 8, I'll get 0.625 seconds. So in air it took 0.625 seconds, and in iron it took 0.625 seconds, and in air it took 10 seconds to cover this distance. Is it clear, children? 11th is also homework. So we'll continue with the B part of the chapter. Infrasonic, sonic and ultrasonic frequencies. Infrasonic, sonic and ultrasonic frequencies. Now, we cannot hear sound of all frequencies. Okay. So now there are human ear can hear sound only of frequency 20 hertz to 20,000 hertz or 20 kilohertz. You can say 20 hertz to 20. Any sound that is produced in this frequency range. Okay. Any sound that is produced below 20 hertz or above 20,000 hertz, human ear cannot hear. Okay. But animals can hear and some birds can hear, but human ear can hear only the sound produced in this range. First thing you should know that. And this is called sonic vibration. Sonic vibration. Now, that frequency, the sound of frequency less than 20 hertz is called infrasonic, and sound of frequency greater than 20,000 hertz. See, 20,000 hertz can also be written as 20 kilohertz. Sometimes they write 20 kilohertz. So, sound of frequency greater than 20,000 hertz is called ultrasonic. Is it clear, children? So, these are the three things. Sonic vibrations are the sound produced between the frequency range of 20 hertz and 20,000 hertz, which can be heard by the human ear. And the sound of frequency less than 20 hertz is infrasonic. Sound of frequency greater than 20,000 hertz or 20 kilohertz is ultrasonic. So as I told you, these two human beings cannot hear, but there are some animals and birds that can hear. We'll be seeing that now. So this is the first concept that you should know. Okay. So this is called audible range. The other way of putting it is audible range. Audible means the sound that we can hear, audible range. So the audible range of frequency, keep underlining, the audible range of frequency is 20 hertz to 20 kilohertz. We cannot hear sounds of frequency less than 20 hertz or more than 20 kilohertz. Okay, the sound of frequency in the range 20 hertz to 20 kilohertz is called sonic or audible sound. Sound of frequency less than 20 hertz is called infrasonic, while the sound of frequency greater than 20 kilohertz is called ultrasonic or ultrasound. Okay, there's one more information here. The human ear is more sensitive in the range 2000 hertz to 3000 hertz. If any sound is produced in this range, even a very feeble means sound of less volume also you will be able to hear. So this information you can know, you can remember. Human ear is more sensitive in which range? 2000 hertz to 3000 hertz. Now one more information you can underline. Animals can produce and hear sounds of frequency below 20 hertz as well as above 20 kilohertz. Another thing, children, we cannot hear infrasonic and ultrasonic, and we cannot produce also. Remember that. We can neither produce ultrasonic and infrasonic, nor we can hear. But animals can produce as well as hear. Not all animals. So there's a table given which gives some interesting information. Bat can hear sounds from 10 hertz to 100 kilohertz. Cat is this and all that. Okay. So bat can hear infrasonic sound also, means less than 20 hertz it can hear, and it can also hear ultrasonic because it's greater than 20 kilohertz. There are some dogs that can hear also ultrasonic. Now the dogs that they use for investigation purpose and all that, okay, they use ultrasound. Okay, they produce whistles that will produce ultrasound. We cannot hear, but the dogs can hear and they will respond to it. Is it clear? So some animals can a dog can hear sounds of frequency up to nearly 50 kilohertz, but bat up to 100 kilohertz. Dolphins can hear up to 150 kilohertz. Now there are special whistles called, for dog it's called Dalton's whistle. Even if they blow, you can't hear it, but the dog can hear it. Okay, now we go to so you would have heard this, but out of these three, ultrasound or ultrasonic is a commonly used word, yeah, especially in medical field. Okay, when you go to hospital and you have a stomach pain, they'll tell you to take a ultrasound. So what is so special about ultrasound? Okay, so in many of the applications, ultrasound will be used. Ultrasonic waves will be used. They don't use infrasonic or audible range, but they use ultrasonic waves, especially for diagnosis and all that. Okay, we have read the sound of frequency is called. Ultrasound can travel quite freely in solids and liquids, but in gases its intensity falls. In a medium, it travels with the same speed with that of audible sound. You remember one more thing you have to remember, children. Ultrasound, ultrasonic, infrasonic waves, all of them travel with the speed of light only. Their speed will not change. Speed will be this one. It's the frequency that will change. Okay, so that's why they have given in a medium it travels with the same speed. Don't think ultrasonic means ultra, so it will be very faster. No. It won't be faster. It's only the frequency that it will increase. You remember what is, so an ultrasonic wave means it will have close waves like this. Infrasonic, less frequency, it will have a wave like this, but speed will be same. Okay, now this is an important point to be noted, and this comes in 2 marks question. What are the properties of ultrasound that makes it very useful? Okay, in all the diagnosis purpose they use ultrasound. What are those properties? One is energy carried by ultrasound is very high. They carry a very high amount of energy. Second, ultrasound can travel along a well-defined straight path. If you send it in a particular direction, it can go without. Okay, so whichever direction you send it, it goes in that particular direction. It doesn't get deviated here and there. Okay, so you can, it is enough if you write till this, it's enough. Okay, then applications of ultrasound, where do they use? The first application is bats. It's something that happens in nature. Okay, rest all are man-made applications. This is something that happens in nature. Bats avoid obstacles by producing and hearing ultrasound. You know this, that during daytime bats cannot see. They are blind during daytime, right? But how are they able to figure out their obstacles if they cannot see? What they will do is, okay, as they fly, as the bats fly, they keep sending ultrasonic waves. Okay, so this is the bat and it keeps sending ultrasonic waves in all directions. It keeps sending ultrasonic waves in all directions. Now if there is an obstacle here, obstacle means a big bird or something is here, then it will hear a echo. Okay, the sound going in this direction will get reflected and come back. This is an obstacle, this is the bat. So as it flies, it keeps sending ultrasonic waves in all directions. If there is an obstacle in a particular direction, that wave will come back. That is called echo. Now this bat is very smart. Depending on the direction from where it is coming, it can guess that an obstacle is in this direction. Also, it can even guess the time, how much distance, depending on the time it took for this wave to come back. It can even judge that this obstacle is very close, so I better take a different path. Can you understand? It can judge both the time and direction of the obstacle. Time means how far it is and in which direction. So accordingly, it will change its path. If it knows there is an obstacle here, it will change its path and go on some other route. Okay, what a great invention of God or creation of God. Yeah. So sometimes they ask how bats avoid their obstacles. Okay, so this one you have to write. By producing and hearing ultrasound, they produce ultrasound which returns after striking an obstacle by hearing the reflected sound, they judge the direction of obstacle in their way, and from the time interval, they can receive them back. They judge the distance of the obstacle. Both direction and distance can be found out. Now we go to the other applications. Next we have industrial applications. In book they have not given as headings, children. They have given it all together. I want you to write it separately. Industrial applications. This is an application that happens in nature. That industrial application. Ultrasound is used for drilling holes or making cuts of desired shape. Okay, if you want to cut a glass or something, they use ultrasound. Next is for cleaning minute objects such as part of watches and electronic components, ultrasound is used. Basically, ultrasound will set anything into fast vibration. So, if there is any small watch part or something, there is some dust stuck in it. To take it out, you allow it to vibrate faster, the dust will automatically come out. Third one, it is enough if you write till this. Okay. Third one, for detection of defects in metals, ultrasound is used. To check whether there is a crack or anything, they keep sending ultrasound. Then come to the next one, medical uses. That was industrial uses, now medical uses. There are 3 medical uses. Again, first one, ultrasonography. This we have heard in hospitals very often. Ultrasound. What is ultrasound? It is used to obtain the images of patients' organs such as liver, gallbladder, uterus, etc. And what is it used for? To detect stones, tumors, etc. in them. Okay. Now the second medical use is echocardiography. The short form is ECG. You would have heard sometimes if somebody has a heart problem, or they'll tell them to go and take a ECG. What do they do there? It is used to obtain the image of the heart. It will help them to understand whether there is any problem in the heart. Third medical uses, it is used in surgery to remove cataract and in kidneys to break the small stones and small stones into fine grains. Okay, in surgery to remove cataract in the eyes, there is a layer that is formed, and in kidneys, if the stone is very big, by sending ultrasound, they break it into fine grains or smaller pieces, then it easily comes out through the urine or something. So it's very easy to get rid of it. Okay, then there is another one called sonar. Sonar is sound navigation and ranging. This they use in ships and all to find the depth of the oceans. Okay, and this part I'll do it later in Zoom class. Now the homework for today will be those numericals. They are very, very short, one line only. Plus you're going to write these 3 answers, 10, 11 and 12. 10th, state 2 properties of ultrasound that make it useful. They have given very short. I want you to write the whole point, that is I have marked there. Then explain how bats locate the obstacles and pray in their way. Third one, I want you to change it slightly. State 3 applications of ultrasound, industrial application and medical. 3 industrial application and 3 medical application I want you to write. Hope it was clear, children. Finish your homework and send it to me. Thank you.